If I asked you what the biggest challenge facing humanity is today, what would you go for? Now I'm guessing and I'm hoping that climate change will be right up there at the top of your list, because the planet Earth is warming. Since 1906, the average global surface temperature has risen between 0.6 and 0.9 degrees C. And although that doesn't sound like much, the effects could be potentially catastrophic. We've already seen the effects of climate change. Climate-related disasters like hurricanes, floods have tripled since 1980. Warmer oceans means a rise in sea level and terrible coral bleaching. And also many species have been forced to move to cooler climates or simply starve to death. Climate change is man-made. We're burning fossil fuels and that produces carbon dioxide. That's just science. And then that carbon dioxide, CO2, along with other greenhouse gases, traps a lot of the energy that would be escaping to space. That causes an enhanced greenhouse effect and warms up the planet.
It strikes me that school students are, in the main, concerned about their environment.
In 2015, global leaders met at the United Nations Climate Change Conference in Paris to discuss global action to reduce climate change. And they came to an agreement to reduce global greenhouse gas emissions and to limit global temperature rise to below 2 degrees above pre-industrial levels. It's called the Paris Climate Accord, or the Paris Agreement, and every single country in the world has now signed it. But last year, in 2017, US President Donald Trump decided to take America out of the Paris Agreement. So the fate of the climate is still very much in danger.
Are we going to change our lifestyle in order to reduce the amount of greenhouse gases we're putting in the atmosphere? Or are we going to carry on living as we do now and not make those changes? And how the Earth's climate will be in the future will be in part dependent on which one of those pathways we choose to take. And that's not just us as individuals, but it's us as a global community.
The Institute for Research in Schools, IRIS, is launching a brand new project called MELT to help school students play an active role in protecting the future that they'll be living in.
The MELT project is an amazing new project from IRIS, which allows young people to genuinely make a contribution to the debate on climate change. It's in two parts. First part is looking at the carbon footprint of their school, their community, their family, their journey to school, their lives. And then the second part is looking at Earth observation data from satellites at the poles. In most schools now, students run some kind of eco-warriors environment club. They want to make a difference. And here's a chance that school students can genuinely quantify what they're doing and seriously take steps to see what direct reduction they can make. And the common calculator which we've built allows them to input in loads of different figures and be completely shocked when I did it about your actual carbon footprint and what carbon you generate every day. They can find out what their carbon footprint is in their school, they can start mechanisms to reduce that. There's loads of different ways of actually tackling their environment, looking at their carbon footprint and trying to reduce it. And then the challenge, trying to actually extract carbon from the atmosphere. And that's very much part of Robert Swan's mission. He's a polar explorer who went to the South Pole purely on renewable energy. And we said we'd work with him to try and complete his Climate Force Challenge, which is to remove 326 million tonnes of carbon dioxide by 2025. So I would very much like the students to be collaborating with the site manager, the bursar, to actually definitely save the school money in terms of reducing the wastage of energy, which many schools have. I was looking at an output from a school just recently where they'd obviously left something on overnight on a Thursday and it was 300 quid just out the window. If they're signed up, they will get access to be able to look at data from the carbon calculator from other schools. And one would hope this would be in friendly collaboration, that they can share ideas about, is it best to let the school be colder over the weekend and warm up gradually on a Monday, for example. But there may be a bit of competition about who can do the best project to actually make the biggest difference. Because obviously all schools are very different. I've just been in bright new modern building and a very old Victorian building. Some of it is the structure, but that's not, we can't say, oh, we can't do anything about it. And I don't think young people think that. I think they want to make a difference, and here's a chance for them quantifiably to tackle this problem and to work with other schools and think up what's good solutions for reducing their carbon footprint.
Hi, my name is Dr. Anna Hogg, and I'm a research fellow at the University of Leeds in the Centre for Polar Observation and Modelling. And I'm a glaciologist. The polar regions are really interesting to study because they're changing so much. We've seen from satellite altimetry observations that there are areas of Antarctica that are thinning at a rate of 9 metres per year. So this is the height of a 3-storey building in ice being lost from an individual ice stream every single year, and this is a lot of ice going into the oceans. But I don't use field measurements necessarily for my research. I use satellite observations.
5, 4, 3.
We're in a period now, since about 2014, where the European Space Agency launched a new set of satellites called the Sentinels. And Sentinel-1 is the satellite that we're going to be using as part of this project to study Greenland and Antarctica. And one of the interesting things about that is we've had a total revolution in the volume of data that's being collected from these satellites. It used to be, even just 5 or 10 years ago, that we were lucky if we got one satellite image of some of these areas every year. And now we're routinely collecting an image every 6 to 12 days from Sentinel-1. And this is fantastic because it means we can study change in ever more detail. But what it does mean is we really need more people to help out with looking at this data. So Sentinel-1 is a microwave satellite. And so what that means is it observes microwave frequencies. It's actually a C-band radar. This is different from, say, cameras. Multispectral satellite imagery is like that. You're viewing the Earth's surface with visible light that you see with your eyes. And we're doing exactly the same with Sentinel-1, it's a slightly different frequency, slightly different part of the electromagnetic spectrum. And so it means, actually, that it's got some really exciting properties. Microwave frequencies can penetrate through cloud, and so that means we can observe the Earth's surface, even when it's cloudy. This is really important for glaciology because in the polar regions as well, it's dark for 6 months of the year. Because Sentinel-1's an active sensor, it means even in the dark polar winter, it can still take images of these glaciers, and that will be why you've got year-round data sets to look at on the glaciers that we're going to study. First of all, the students will go to the Ice Velocity portal, which we host here at Leeds, and they'll go and log on, and they'll choose which ice stream they want to look at. The ice streams that we've got on there are Petermann Glacier, which is up in northwest Greenland. We've got Jakobshavn-Isbrae, which is on mid-west Greenland. And then in Antarctica, we've got 2 really interesting ice streams called Pine Island Glacier, which is somewhere that I spent 3 months of my time doing field work, and also Thwaites Glacier. Thwaites is just next door to Pine Island. These colossal ice streams export vast amounts of ice from the Antarctic and Greenland ice sheets out into the ocean all of the time. And they do this by carving icebergs. And so you'll identify, first of all, where the ice stream is. You may identify some other really interesting glaciological features that you'll find in the images, such as either melt ponds on the ice in the summer, sea ice in the ocean in the winter, or even icebergs themselves floating around in front of the ice streams. Then you'll learn how to make shapefile measurements of the carbon front position. And there'll be instructions provided about how to do this. And while you'll make a measurement of one individual image, your classmates or maybe colleagues from another school could be measuring the same glacier's carving front, but at a different time period. And what you see when you pull all the observations together is that actually this isn't like a static feature in these images. It's changing, and it can change maybe just every 6 days, or there might be a bigger feature or a big carving event that happens only once, and it's a really dramatic thing at one time period, and then it's calmer and less active throughout other parts of the year. So it's always really exciting to keep an eye on these ice streams because you never know when something's going to happen. You can genuinely discover something new that we didn't know about how the Earth worked. There's so much satellite data available now to us that this is a great opportunity to get stuck in and to see things that scientists haven't yet found out. We've got images of the planet that are now being acquired by satellites that no human may ever have looked at, and so this is your chance to really get involved in doing a measurement that we would be doing in universities or research labs around the UK and in Europe, and contribute to science today.
MELT stands for it shouldn't really stand for anything, because it is about the melting ice caps and what impact that has on the earth, but it stands for monitoring our environment, learning for tomorrow. But it's about giving young people a chance to genuinely make a difference to impacting their environment. And it's their future and they're concerned about it. Let them have a chance to collaborate and work together to make it better.
It's going to take understanding and a lot of elbow grease to slow down and ideally stop global warming. Iris and Melt is a part of that. It's brilliant. It empowers young people to take action, to get involved in protecting the future, their future. Just go to the Iris website, head to the Melt page, sign up, and let's conquer climate change together.